muscles can push. And I'm going to prove that by simply moving my arm. But first, let's just see what Google has to say. The primary muscles involved in the action of arm abduction include the supraspinatus, deltoid, trapezius, and serratus. They're not including the Latissimus Dorsi or the pectoralis major. And that's because they're not considering the pushing motion, or what I will call negative tension. The current model of how muscles tense and the forces they create is the length tension model. It only shows tension, that is to say pulling. The reason it only shows pulling is because they used a machine that only measured pulling. Even this graph shows that at a certain point, the muscle stops pulling past that point because something else is pushing. The same way, if I push against a wall, the wall pushes back on me. This is Newton's third law of motion. What I'm going to show in this demonstration, this experiment, is that there ought to be a line that goes into the negative space in this graph. Here's the basic setup for my experiment. I have measuring tape on the stack, and I'm in the same position each time, and I abduct my arm across as far as I can. Now, the muscles that are conventionally said to abduct the arm are not strong enough for me to lift this weight. My deltoids or my shoulders can't lift weight this heavy. What I'm actually doing is pushing the weight with my Latissimus dorsi. The more compressed the muscle is, the more weight it can move, and it moves the weight until it reaches an equilibrium point. So the point where I can't move my muscle anymore tells us how strong the muscle is at that particular length, or squishedness, to use a technical term. Going down the weight stack, I'm able to measure the weight and the length I can push it and graph it on this graph showing negative tension of the Latissimus dorsi. Past a certain point, obviously, the latissimus muscle pulls. So I found the 0 point between those points. I found how much weight I could abduct my arm past that point using the conventional muscles like the deltoids. And I minus that from the graph to show how much I'm pushing with the Latissimus dorsi. It's not going to be a 100% accurate method, but it will do, and this is a repeatable study, so people will do it better in the future. Next, I'm going to try and document eccentric negative length tension.